Hi everybody. So in today's video we will have a further look on the blink coding and example. So in earlier videos we actually worked with one LED in pin number 13. So today we will try to have two LEDs and we will see how we can customize the coding for that, and also if possible we will try three also, right? So let's try the algorithm first. So let's do like this, okay? So we have an LED on pin number 13, right? Let's say we are in the earlier videos we had a look on that. So if you don't know about that, just go back to some previous videos of mine, like last 3 or 4 videos, have a look and come back to this video. Okay, that's fine. So we already have, let's say we already have a LED on pin number 13. Along with that we are trying to have one more LED. Okay, so we are going to have two LEDs with the same pattern, right? So both of the LEDs should blink, okay, in the same way. Okay, both the LEDs should blink, should on at the same time, and they have to be on for 1 second and they have to go off for next 1 second, right? The same thing, 1 second on, 1 second off, and 1 second on and 1 second off. This time two LEDs, same behavior, same time. Okay, so let's write this algorithm first. So let's say how can I say that, like, okay, okay, LED 1, let's say LED 1, I have written L1, so that's easy. So L1 comma L2, on, right? So what do you say, on? Okay, on. Okay, so when at t is equal to 0. So if you don't understand what I'm talking about, go and go have a look at the last video. Just watch the last video and come back. So that means when the program starts, t0 means what? The time is 0. So let's say in the void loop, when the program starts, both LEDs should be on, right? That means at the beginning both the LEDs should be on. That means time is 0. Time 0 means what? The program is just beginning. Okay, then what is our task? After 1 second, both LEDs should go off. So that means at t is equal to 1. So let's say the t is time on seconds. Okay, so when t is equal to 1, both should go off. Okay, so let's write something like this. So then L1 comma L2, okay, of t is equal to 1. That's acceptable, right? So then what should the thing, and also remember in the last videos also we did the same thing with the one LED, but I didn't have the T0 T1 business in the last 1 or 2 videos. So in the last video only I explained this stuff, so I thought adding this part will be more explanatory, right, and people can understand better, so that's why I added it. So then after 1 second, for 1 second it is going to be off, right? So first at the beginning both the LEDs should be on, then for 1 second it will be on, no worries, and after 1 second, that means at t is equal to 1, time is equal to 1 second, LEDs start to go off. So the t is the beginning time, beginning of the process. So this t is 1 is also is the beginning of this process. That means at 1 second it starts to go off. So after another 1 second, that means when t is equal to 2, this LED should be on, right? So you may have 2 here, and also after another 1 second, when t becomes 3 seconds, both the LEDs should go off. So I can remove this part. So the same thing is going to repeat, right? So this is the minimum amount of code that cannot be broken further without breaking the functionality. So this minimum amount of code is going to be rotating inside the void loop, right? That's very simple and easy, right? You can understand that. So LED is on, t is equal to 0, LED is off. So if you want, what I can do is I can have a, let's say 1 second wait. Okay, so this 1 second delay, and then okay, L1 L2 should be off at t is equal to 1. So now this is the minimum amount of code that we are going to play around, right? So you cannot break it further without breaking the functionality, and if you add something else to this, then that means you are writing unnecessary part of code, because void loop will itself iterate it and repeat this process, right? So I think this is clear, and you know, and I think this is clear, right? So that's fine. So let it be that way. So let's say let's say L1 is pin number 12 and L2 is pin number 13. So that is clear. So what I will do is, as you know, as you have had a look on the previous videos, so first what we have to do is we have to tell that what we call output, right? Tell these pins are output. So we have to use pinMode, and we have write 12 as output. So pin number 12, that means LED 1 is going to be an output. Okay, so that is fine. Also, we are going to use two LEDs, right? Pin number 13 is also an output, right? So we have to tell that as well. So if you don't understand what I am doing, go watch my last 4 or 5 videos and come back, and then you will understand what I am actually doing here. So pin number 13 also should be said as output. So in the earlier video, we just had pin number 13 only, and we said it is an output. Now what we did is we are having pin number 12 as well. So when you are having an LED in pin number 12, whatever you have done for pin number 13, all the same things you have to do for pin number 12 as well. So because pin number 12 also you are going to use an output, so you are saying pin number 12 is an output. Okay, 12 output, 13 output. So if you still don't understand what I am talking about, just go just go watch my previous videos, let's say last 4 videos, and come back here. Then it will be crystal clear to you, right? There will be no questions actually. Okay, that's fine. So then we know, right, what we have to do. So at t is equal to 0, that means we will consider at void loop it is t is equal to 0. And I also said you in the last 1 or 2 videos, this program, to go from one line to another line, the program takes almost no time. So if you consider this line, the line number 4 is to be t is equal to 0, then also line number 5 is also t is equal to 0 time. That means t is equal to 0 seconds at the beginning, because from one line to another line the program goes in no time. Okay, so in that context, the first line of the void loop also will be t is equal to 0 time, because from here and here program comes in no time unless you have a delay in between somewhere. So just don't worry, at t is equal to 0 we will see what we should do. So what I will do is I will have a digital write as usual, because we already said we are going to use an output. Now we are going to use it as a digital output, right? It's that simple. Okay, digital output. First we said this is an output, now we are saying this is digital or analog. So now this is digital. So if you still don't understand, go have a look on my last few videos and come back, then you will understand. So and what I will do is 12, and first before that I will mention the time. So I will remove this later. So for the means, so let's say this is t is equal to 0. Okay, so what are things should happen? This L1 and L2 should be on at t is equal to 0. So I am first switching on L1, that means pin number 12. So digital, they have to be on, right? So digital write, that means we are giving a digital output 12, and on, since it is on, it should be high. That's that much clear. So now for the t is equal to 0, what can be the second line? At the same time we have to switch on that pin number 13 as well, right? So I will copy this line. I'm sorry. Okay, let's copy the T0 also. No, let's not copy the T0. Copy and paste. So both are happening in t is equal to 0. So if you don't want, I will add the t is equal to 0 part as well. So again here also the t is 0. Okay, so both are happening. Both are happening at the same time. So this is also T0 if you want I can add, but I don't want to add that, right? So the first part of this algorithm is done. So L1 and L2 are on at t is equal to 0. So L1 is 12, L2 is I had to change it, L2 is 13, and on means high. So because we have already said these are digital, these are output pins, and the output type is digital. Okay, so because LEDs are digital, go have a look on my previous videos and come back if you don't understand this. So now what is that? At t is equal to 1, they have to be on, right? That means we are going to have 1 second delay. So I wrote that part as well in the, for God's sake, in the algorithm. So what we will have is, this is also at t is equal to 0, because we are writing that starting time, starting of that line, when the line starts, when the program comes to starts, what is the time? So from this line to this line also it takes no time, right? T is equal to 0. After the delay only it takes some time, right? So when the delay starts, it's still t is equal to 0, right? So I will have 1000 millisecond delays. Okay, now what happens? We have waited 1 second in the line without doing anything. So 1 second has passed, and once the when this delay 1000 is finishing, it is t is equal to 1, right? So at the same time, with no time, it comes to the next line, right? So in the next line we will have t is equal to what? 1 second, because we have had the 1 second here. So that 1 second will be added to the 0, and when the next line starts, t is equal to 1. So now what we'll do is we will go to the next, we have 1 second delay, we are done, next line of code. So we are saying at t is equal to 1, L1 and L2 should be off. Okay, so I missed another part in the coding. So after that also we should have a delay, right? After switching it off as well also. So 1 second delay, because we have to say how long it has to be switched off, right? So that's fine. So now what we will do actually is at t is equal to 1, I will switch off both of these LEDs. So what I will do is I will, oh my god, I will delete something, it seems. No, I will write only, copy only one line. Is that thing okay? I will paste it here and I will make it low. Okay, so now I am making pin number 12 is low. So this is true at t is equal to 1, L1 is low, and L2 is also should go low at the same time, t is equal to 1. So since there is no delay now, so if you write the same another line here for switch off L2, so that also will be in the same time, that means t is equal to 1. So I hope this is clear. So digitalWrite 13 low. Okay, so that's more beautiful, right? Low. So what's the time now? Since from here to here, when the program starts at t is equal to 1, so there is no delay in that line. So that means what? When we are going to the next line, it goes in no time, right? So the same time will be there since there is no delays. So t is equal to 1 here as well. So 13 is low. That means we switched off. So this condition is also done. Now what we should do? 1 second delay. So from this line to when we go to next line, what's the time? Still it goes in no time, right? So when the process starts, it is t is equal to 1. So when the delay starts, when the second delay starts, t is equal to 1. So 1 second has completed now. Okay. So the second delay, that means the delay that actually is going to keep the LEDs off for 1 second should also start at t is equal to 1. So after t is equal to 1 second delay. So the thing is, after this line finished, when the program comes to this line, what is the time? It will be t is equal to 2, because we had 1 second delay. Then again after that it will come to the first line, right, without any delays. So when it is coming to the next line, second line, since it comes in no time, right, so this will be 2. So you can see at the beginning of the 0 it is on, then 1 second it stays on, and at the beginning of 1 second at the completion, and at the beginning of the second, that means after 1 second is completed, at the beginning of t is equal to 1, 1.1, 1.2, at that time it becomes off. It's obviously correct. And when it becomes 2 seconds, it again goes on. So it's correct, right? So at 0 it is on, for 1 second it is on. So after 1 second, at the completion of 1 second, and the second start, that means when t is equal to 1, that means when the completion of 1 second means what? T becomes 1. When t becomes 1, the other line it goes off. When t becomes 2, it goes on. At 3, it goes off. So such kind of things could happen. So I think since this is very clear, you can understand this, right? So this is according to the algorithm, this is absolutely perfect, right? So if someone is coming and tell you, okay, I need one more LED, what do you have to do? You have to repeat the same thing that you have done for a single LED. So already we had a look at pin number 13, right? So if you now compare that code with this, you can simply say I have did the same thing for pin number 12 in the next previous lines. So because having two things at previous or next line is like having both of them at the same time. So if somebody is asking you, okay, let's have one more pin. Okay, no problem. What you will do is you simply add pinMode. You know why pinMode is added, right? So that you should be very clear. I'm not repeating it again and again since I have repeated it so many times. Output. Okay, that's it. Then also if that is all the same scenario, then you will have one more line here at the same time. So let's copy this line and paste, and let's say if it is pin number 11, and here also you have to add pin number 11 because you have to switch off that as with the other LEDs. So the times are same since there is, I didn't mention it again. So you have added one more LED. So now you can eliminate 3 LEDs with 3 connections. So it's that simple. You're adding the same lines, just changing the pin number. Okay. So I will remove this part since it takes unnecessary time, but I hope you got the point, right? So you can compare the time. So and also I will remove the time because the time, or I can just comment out the time, right? I wonder how I can do it. The whole line is getting commented then, so I can't comment out the time. If I have to comment out the time, I have to have somewhere else. I mean, maybe at the end of the line. So let's say t is equal to 0. So now everything is fine. So this code cannot run because this t is equal to 0, one part has to be removed. So I will remove that part since you understood that, because I wrote it just for some clarification and people can understand since they are learning. So what I will do is I will simply do this. Okay, so this works according to the algorithm. Okay, so if there's anything you are asked, you can simply compare this algorithm along with the code. So this is just amazing and perfect. And I have to remove this as well. Okay, I forgot that the 11 has to be removed now. We'll just consider the 2 pins according to the algorithm. So now you have a clear idea about how Blink works, how you can add 2 more pins, 1 or 2 pins, and what are the things you are at pinMode and digitalWrite. Yet if you don't have any idea about this, or if you don't understand anything, just go have a look on the last few videos and come back. Then things will be very clear to you. Why pinMode, why digitalWrite, and all those things you will understand very clearly. So that's all for the videos. Please consider subscribing our channel. Until then, until I meet you in the next video, have a great day. Bye.